here. Now we can take this stuff and we can add a bunch of summary statistics to our thing here. So there's a nice function called describe. What describe does is it describes every numerical column in your database, only for columns that contain numbers. So it tells you how many elements there are, and the 114 elements expressed in funny ways, I guess. It tells you the mean of the column, it tells you standard deviation, the minimum, and it tells you the quantiles, the quartiles, I'm sorry, of what each quartile value is. So this tells us that for the lowest 25%, the range is from 150, the range of open is from 150 to 156.265. For the 25 to 50%, it's from 156.265 to 170.365. From 50 to 75, it's 170 to 176, and the max is 182. I mean, this is kind of useful when we're doing our data, our machine learning kind of stuff. But what it tells us off the bat is that the range here is, the first quartile is 6 price points, the second quartile is 14 price points, the third quartile is 6 price points, and the fourth quartile is 6 price points, right? So this quartile here, the second quartile, is sort of a mess compared to everything else. In a nicely well-behaved data, this thing you would hopefully get equal ranges in each quartile, but this is not that well behaved. So now we can use this for quickly looking at some statistics. But our interest is to see whether in general, if we buy at the open and sell at the close, are we going to make money? So let's see what percent of the total days are up days. And now here, and when we're doing this, we can see we can actually do very quickly run functions on our data frames. That's a nice thing about it, right? So we have our data frame, and in the data frame we have the up column, right? So this becomes the up column. So we can say for the up column, compute the sum of all values. Okay, so it's going to add up all the ones basically. Divide that by the count of all items in the thing here. So the count is 114. So we add up the number of times there's a 1 by the number of 14 by 114, and we get the percent that we are interested in. Note that you're doing it on a different day, so you probably have more than 114 elements. Okay, you should have anyway. So this tells us that 48% of the time we are going to be, we can, if you like, we can multiply this by 100, so that we get a nice percent. 48.245% of the time we are going to be getting the close being higher than the open. So if we, assuming we don't care about differences at this point, in general we will lose money, or we would have historically lost money if we had followed the buy at open, sell at the close policy, or the number of days. Of course, we might be, I mean, the strategy might still work because the up days might be more powerful than the down days, but we don't know all that, right? So just in principle, so this is a very simple analysis. So so that's the goal here. Now, so what can we do? We can take a data frame, we can compute summary statistics on all numerical columns, and we can apply our own transformations and operators on those values to get stuff from there. We can create new columns using elements from the old columns, which is kind of nice, and do analysis on that as well if you want to do that. So now what else can we do with this? So there's a lot of stuff we can do because we are working with time series data, and we can see that time series data is ordered by time, and that's the way our data frame is structured. So we want to be able to use some do some time series analysis on it across the time. So there's a bunch of functions that Pandas provides us. The first function is percent change. And what percent change does is, given a column, so let's take the close column for example, right? Given the close column, you can apply the percent change function to that. So what this is going to do is it's going to give you, for the close, it's going to give you, let's say that's the close, so it's going to do the percent change for, oh, sorry, that's not the, that's the describe thing here. So here the close is 167.19, 169.26. So we're going to get, we're doing a 1 day percent change. So the percent change for 2017-01-03 is going to be unknown since we don't know the previous day's close. But for 04, the percentage change is going to be 169.26 minus 167.19 divided by 167.19, and we're going to get that value there. So let's take a look at that. Gives us a 1 time period percent change, and that's what we get here. Very conveniently done because it's time series data. The nice thing is that we can actually give it an argument, and we can some number, and it'll give us a n day percent change, which means in this case, like for example, a 2-day percent change would be 168.70 minus 167.19, 2 days divided by 167.19. So it'll look at the price n days before and compute a percent change based on that. But this is very useful for technical analysis. So we can do that. So we get initially we'll get nans because we don't have 13 days of data. So the moment we have 13 days of data, we can start getting our percent changes. Pandas function can ignore nans. So wherever there are nans, it'll just ignore that. So like our percent change here, for example, has a bunch of nans in the beginning, and you want to compute the mean on the column. So it'll give us a mean with the nans ignored. So that's a nice thing about it. Nans are just ignored by it, and we can work with that. We can create rolling windows. Rolling windows are very nice because what you want to do is, so in the percent change, what we're doing is we look at the 13-day percent change is taking the price today and looking at the price 13 days ago and looking at the difference, right? However, what we might want to do is we might want to compute moving averages across this thing. So we might want to compute a 21-day moving average of a 13-day price change. So what you want to do is you want to construct windows of 13 days each, of 21 days each, and for each 21-day window, we compute an average, then slide the window by 1 day, compute a new average, slide the window by 1 day, create a new average, etc. So Pandas has a rolling windows function. What it does is it extracts windows. So from the data series, so we have a data frame. From the data frame, we extract the closed column. We compute an n-day percent change where n is 13, and we compute 21-day rolling means on that. Rolling windows on that. So this constructs an object that contains all the windows. It doesn't. It's a generator object. It doesn't actually construct the windows, but it will give us the windows when we need it. When do we need the windows? When you want to construct, for example, the mean. So what this is going to do is it's going to construct the mean for the 13-day percent change on a 21-day rolling window. So we're going to get an initial set of nans because we need 13 data points for the percent change and 21 data points for the rolling window. So we need to get 21 13-day percent changes. So we need 21 plus 13 data points before we can start getting any values. So you're going to get those many nans first, and then this is the moving average that we can do on that. So we can construct many of these. For example, I'm going to construct here an 8-day, a 13-day, a 21-day, a 34-day, a 55-day moving average on our 13-day percent changes. So I get a whole bunch of them. And then if I want to plot them, all I need to do is to use the function .plot. So what .plot will do is it'll take a data series, a single series, and draw a graph out of it, right? So here I'm going to plot the 8-day and the 34-day average. Just take a look at it, and we get a plot that looks something like this. So this is the missing data, the initial 21 plus 13 days, which are nans, right? Because our data series contains nans. And then this is the two moving averages. We can see that the 34-day moving average is the smoother one, and the 8-day moving average is the noisier one because it's shorter. And you can kind of see that. So you see that the 8-day moving average is kind of low all the way down, and then it sort of took off. So I guess this is where IBM is now outperforming itself historically. So that's the basic stuff. We take what have we done? We can take our constructed data frame. We can do some very basic time series stuff with it, like compute percent changes for different time periods. We can get rolling windows, and the rolling windows we can draw anything we like, the means, the standard deviations, maybe write other functions on it. It doesn't really matter, right? You can do whatever you feel like with that. But that's what Pandas provides us. So as the last piece we will look at in the next unit after we finish this one, now that we're done with this one, is we'll look at very simple analysis using Pandas. So get ready for that.